All right, let's take a look at our stretches and compressions. We need to graph f of x equals the absolute value of x. So I'm going to do that in a table. Here's our x value. Here's what we get back with f of x, which is the absolute value of x. And they gave us a domain from -4 to 4. Remember, that domain is your input, it's your x values. So I want to start at -4, and then I'll skip a couple. I'll go -2, 0, +2, +4. That's covering the domain that they gave us for the function. So when you plug these values into our function, absolute value of x, we're just looking at what is the absolute value of -4. What's +4? What's the absolute value of -2? +2. What's the absolute value of 0? 0. So all I'm doing is I'm taking these x values and plugging them in for that f of x function for the x right there. The absolute value of 2 is 2, and the absolute value of 4 is 4. So we can plot those points. That's going to let us graph f of x equals the absolute value of x. So we had -4, 4, -2, 2, 0, 0, 2, 2, and 2, 4. And the domain has us include those endpoints at 4 and -4, so we're going to have closed circles there, and then we'll just draw this in. So that is our f of x function. Okay, now they want us to find g of x, and so let's just add onto this table. Our g of x is going to be 2 times whatever the f of x value was. So when we look at 2 times, so our -4 value, when we plug that in for x, our f of x value is 4. So we're going to take this and multiply it by 2. So we're going to do 2 times 4, and we're going to get 8. So our ordered pair will be -4, 8. So these x's are the same x's we're using. They're telling us to get the g of x value to take 2 times what we got for f of x, which was these values. So I'm just multiplying these by 2. We're going to do 2 times 2 to get 4. So we have the ordered pair -2, 4. 2 times 0 to get 0. So that's still 0, 0. 2 times 2 to get 4. So we have 2, 4. And 2 times 4 to get 8, which gives us 4, 8. So these are our new ordered pairs right here. I can see the domain is still from -4 to 4, so we're good. So let's go ahead and plot those points on our graph, and we can see how the graph looks different when you multiply the function by a 2 out front. So -4, 8 is up here, -2, 4 is right here, 0, 0, 2, 4, and 4, 8. So visually, we can see that our original function got stretched. It's just stretched up. It had a vertical stretch. And then this 2 right here is the factor by which it's stretched. It's stretched by a factor of 2. You can see that all of your f of x functions, your y's of the original graph, doubled for the y's of our new graph. How are the domain and ranges related? Well, domain is your x's, goes from -4 to +4 for both graphs, so your domain did not change. Domain is still from 4 to 4. But let's look at that. Oops, that should be a bracket. The range did change. The range of our original function went from 0 to 4, and the range of our new function went from 0 to 8. So you can see that our range increased by a factor of 2 as well. It went from a 4 multiplied by 2 to get an 8. So when you're multiplying your f of x function by a number out front, that will stretch your graph. If it's a number greater than 1, it's going to stretch it. If it's a number less than 1, it will compress it and kind of shrink it. Okay, next example, graph f of x equals absolute value of x. So I'm going to pause and do that. We already know how that graph is going to look. Okay, so there's my f of x function. One thing you want to think about is your domain. Our domain is going from -4 to 4. Our new function is multiplying the x, which is your domain value, by 2. So we have to be careful about that. If we plug in a -4 right here, we're going to have 2 times -4, and we'd be looking at f of, f of -8. And now our new domain for g of x would use a -8, and that's too big because we have to stay from -4 to 4. So I'm just going to go ahead and tell you that we can do a table of values starting with -2, -1, 0, 1, and 2, and figure out our ordered pairs for our new function. So these are your x's. G of x is equal to f of 2 times x. So remember, your f function is the absolute value of x. So in this case, we're going to do the absolute value of 2 times -2. 2 times -2 is -4. Absolute value of that is 4. So our new ordered pair is -2, 4. Now we're going to do the absolute value of 2 times our new x, which is -1. Absolute value of 2 times -1 is -2, gives us a +2. So we have -1, 2. Absolute value of 2 times our x of 0. 2 times 0 is 0. Absolute value of that is 0. So we still have 0, 0. And then I'm just going to fill in the rest of this chart. Okay, so that's filled in. You can see we have some new points to plot. So I'm going to pause and plot those points, and we can see how our two graphs compare. So in green, there's our new function, g of x, after that transformation that they had us do right here. So comparing the domains and ranges, well, I can see that the range is the same. Both graphs have 0 as its lowest point and 4 as its highest point. But the domain did change. The domain of the original graph went from -4 to 4, and the domain of the new graph went from -2 to 2. So when we had this 2 times x right there, it actually cut our domain in half. This is what we call a compression. It's a horizontal compression because it compressed horizontally. And then we have just a little recap down here. I know it's kind of small, but basically, if your constant k is out front, some number that you multiply by your f of x, that's going to stretch or compress vertically. If you multiply k times the x inside the parentheses, that's going to stretch or compress your function horizontally.